All right, so now that we know what a factor tree is, we're going to make a factor tree for 72. So we're going to start with 72. And I always just like to think of the first two factors that come to mind, which for me are 8 and 9. 8 times 9 equals 72. But remember, we want to get all the way down to our prime factorization. So 8 and 9 are not prime numbers. They still have factors. So 8 can be factored into 2 and 4. 2 is a prime number, so I'm going to circle that. 4 is not prime, so I'm going to keep breaking that down into 2 and 2. So I can circle both of those. And then 9 factors into 3 and 3. So those are both prime, which means we can write our prime factorization as 2 times 2 times 2 times 3 times 3. A more simplified way of doing that is to actually use some exponents. So we could write this as 2 times 2 to the second power times 3 to the second power, or we could even make it one step further, 2 to the third power times 3 to the second power. So next we want to simplify the square root of 72, and in simplifying the square root of 72, we're going to use that factor tree, which is why we did that first. So when we take this prime factorization right here, we can actually rewrite the square root of 72 as the product of all those square roots equals the square root of 2 times the square root of 2 times the square root of 2 times the square root of 3 times the square root of 3. That is one of the properties of square roots, is that you can break it down into the product of its square roots. However, this one isn't going to be as helpful for us, but we can make it work, because the square root of 2 times the square root of 2 is actually going to be 2. Any square root multiplied by itself. So that's really the square root of 2 squared. And remember, square roots and squares are inverses, so they undo each other. So if we take the square root of 2 and square it, we're just back to 2. And if you don't believe me, there's always our handy calculator to check. So if we take the square root of 2 and multiply that by the square root of 2, we get 2. It just undoes each other because they're inverse operations, just like multiplication and division. So we know that that's 2. Now we just have this square root of 2 that's all by itself. We can't multiply that with anything else. And then we have this pair, square root of 3 times the square root of 3, same philosophy, means that that is times 3. Now we have 2 times the square root of 2 times 3. Anything that's outside of our radical we can multiply together. So we can do 2 times 3. What is 2 times 3? Well, that's 6. And then that multiplied by the square root of 2 just stays, times the square root of 2. So we can actually simplify the square root of 72 to be 6 times the square root of 2, or we can even just write it as 6 square root 2. You don't even need the multiplication sign, as long as the number outside the radical is in front. Let's try one more problem here. Make a factored tree for 120. So the number 120, we're going to factor that. 120. 12 and 10, anything that ends in 0, I always like to start with 10. Again, we're going down to the prime factorization. So I'm going to do 2 and 6, so I can circle 2. 6 is 2 and 3, so I can circle 2 and 3. And 10 is 2 times 5. Both of those are prime. So I'm going to rewrite this out as 2 times 2 times 2 times 3 times 5. Notice I want to put all the 2's together, then the 3's, and then the 5's. I'm going to write it in increasing order. Then we're going to use that to help us simplify this radical of 2 square root 120. So 2 square root 120 equals, I'm going to keep that 2 in the front, 2 times, and then our radical, the square root of 120, we're really making that the radical of its product. So the square root of 2 times the square root of 2 times the square root of 2 times the square root of 3 times the square root of 5. But this 2 in the front is not underneath the radical. So then again, we can combine any two like radicals. So the square root of 2 times the square root of 2 becomes 2 times this 2 in the front. Can't forget that. And then everything else is going to stay the same because we don't have any more pairs. So we're looking for those pairs. We can now simplify by multiplying the things outside the radical. So 2 times 2 is 4 times, and then we can multiply everything inside the radicals. So we can do 2 times 3, which is 6, and then 6 times 5, which is 30. But that's going to have to stay under a radical because all the numbers were underneath a radical. So times the square root of 30. So 2 square root 120 is equal to 4 square root 30. And again, if you want to make sure that you did this right, you can go back to your calculator, type in 2 square root 120, get that decimal approximation, and then type in 4 square root 30. And you should get the same decimal approximation. If you don't, then you did something wrong. That's all for today. Go ahead and go on into your practice.